Hello everyone, good morning. It's a time for class again. This is ECE317 Digital Signal Processing. Welcome. Last time we have studied some signals which have real values. All those signals, the value of them, they are real numbers. Today we will study some signals with complex values. All right. ECE317, this is the third class. We will consider the case x of n equal to a to the n, but a is a complex number. Like I say, it's alpha plus j times beta, like this one. Now what will be the power of a? You understand, right? So complex number, if you do multiplication, that will be somehow complex, right? You have real part, you have imaginary part, and if the power going up, that will be more complex. So if we calculate directly by this way, it is hard. However, we have another way to represent these complex number, which can make things simple. This one, we have a graph. We use graph to see what it is. This is A, then the real part is R, and the imaginary part is beta. So this is A, right? A is alpha plus j beta. Now we consider this one. Here's the angle, and the length of this bar is rho. Then alpha can be written in this way. Alpha can be written as rho times cosine theta, right? This is alpha. This is rho times cosine theta. This is alpha. And the beta can be written as rho times sine alpha, sine theta, right? This is rho. This is beta. This is beta. Beta is rho times sine theta. And then A can be written as rho times cosine theta plus j sine theta. Right? Both alpha and beta with term rho, so I moved it in the front, and the theta is keep it here. Then this is rho times e to the j theta. So here we use this one. E to the j theta equal to cosine theta plus j sine theta. It's a Euler formula. We have this way. Alright, by this way, then we can have a to the n equal to rho to the n and the e to the j theta to the n. Rho to the n, the same thing. E to the j theta. This is a exponential power, right? Then take n times, you just multiply inside. So this is j theta times n. So we have this one. So it's not so complex, right? Not so complex. If you want to write, go back to the form real part plus j imaginary part. This one can be written as rho to the n. Okay, still use the Euler formula. It's a e to the j theta. Then here's cosine and sine of theta. Now is e to the j theta n. So here is a cosine theta n or n theta, and the j sine of n theta. So we have this one. See? So we can have a of n quite easy. Alright. If rho is 1, then we have x of n, it is just because rho is 1, right? So a is just e to the j omega, j set. So this is e to the j set with power n. So we can have x of n, this one, right? X of n, this one. Yeah, that's it. Just like this, right? Yeah. Okay, so this is x of n. Yeah. It's a complex one. And how it looks like? This is you have two. So we can, if you want, you can write in this way. This is n, and you use here's a real, here's an imaginary. You have two x's for x. Then for every n, you will have some point here. When n is 0, oh, this one n is 0. This is just 1. And say, right? N 0, this is just 1, the real part, 1. When n is 1, this will be a still here, so it will be some point here, okay. Depending on the value of set. Set is here. And the next point, there will be two set. Set, they go to that side. And the next n, they even go down to here, right? Down to here. If you have one more, you check one more n, then right, the set is 1, 2, 3, 4 set. This is here. So the same like this. Yeah. And then turn around. So actually it looks like this. It's like screw, right? Turn around. We use computer to see. Yeah, you can make it more clear. Okay. I use an n, run from like a 0 to, I try 30 point. These are n, and I need to choose a set. I use omega for the angle, w for the angle. I use what will be the pi over like 6, not 6, 5, 6, 7. The larger doesn't matter. I don't know. I have this omega, then I have x, which is exp of j times, this is angle w, then times n. Okay, you see, we got 31. Yeah, start from 0. 31 numbers. They are complex numbers, right? Some real part plus the imaginary part, and then we can plot it. Okay, now I need a 3-dimensional. Plot x. What is this? Oh, cannot accept it. Okay, I need to write in this way. I have 1-dimensional is n. Second dimensional is the real part of x. So it's a real part of x, and then imaginary part. I think it's im or imeg. This one? Oh, okay, it's fine. See, it's a screw, right? Okay, I can give more. Here what is n? I use 30. I double it a little bit more. 70. Okay, 70. N is 70. Then x is use same formula, exponential power of j omega to the n. Okay, and then plot it. Plot 3-dimensional. Okay. This one looks better. Yeah, it's just turn around, right? It's turn around. It's cool. And this side will be n, from 0 to 70, right? I run 70. I picked 70, I think it's not 7, yeah, 71, 70, yeah, pick 70 point, and run from 0 to 70, and these two axes, one will be the real part, one will be imaginary part. When the n is 0, the value should be 1. Okay, this is 1, so 1 is the real part. So here, this line is real part, and this axis is the imaginary part. So we just start from here, then turn around, yeah. Okay, so this is a signal with a complex value. Okay, this is the example that rho is 1. Right? Here I suppose rho is 1. If rho is not 1, then things will be a little bit different, right? I can keep doing these exponential power, this to the n. I move n outside. I do this one. I times the rho. Suppose rho is a 0.8 times rho times this exponential power of j omega, and then the whole thing I give power like this way. I use this as x. Then if I plot it, plot 3, what can we have? Oh, it's turned around, tend to be 0 too fast. Okay, then I use a larger n. This 0.8, I use 0.98. Is this enough? Might be too large. Anyway, we just try. Okay, this is x. Then plot, 3-dimensional plot. Okay, this is fine, right? Still like a spring, right? It's turn around, and this spring turn around smaller and smaller, right? Yeah, because we have a power of rho, and rho is a number smaller than 1, so it tends to be smaller and smaller. If I use a larger one for the rho, like x is 0.9, so I use 1.08. I use this one as rho. Then plot it, how it looks like. Oh, this way. So it still spring stuff, but in the beginning it's small. Turn around, right? The readers is small, and when n increase, the reader turn to larger and larger. And here's like in the scale 100. Right? This is 100. You see the scale on the axis, real part and imaginary part. This is 100, and this is 250. Right? Yeah. So tend to be larger and larger. Okay. So this is the two examples with a complex number in the signal. Okay. Then we consider another thing is kind of operation of signals. Operation of signals. Operation of signals. So if we have several signals or one signal, we can make some change, then we can have a new signal. Okay. I use the example to explain it. Suppose x of n looks like this. It's 1, 2, 3, then 3, 3, 3, and 2, 2, 2, then 0, and here is also 0. Okay, like this. So the value we have, the first is 1, second is 2, then 3, 4 of them are 3, 3 of them are 2, then 0. we can also write in this way. It is 0, before 0 something, actually all of them are 0. And then we have 1, we have 2, I have 3, 3, 3, 3, I have 4 3s, and then 2, 2, 2, then 0, 0, like this. And this side is n equal to 0. So we suppose this is x. Now we can consider this is x of n, right? This is x of n. We can consider like y equal to 2 of xn. What is this? Secondly, y of n. Yeah, I put the n. Y of n. And second, y of n is still 2 here, but inside I have a 2n minus 1. Inside the tank I have this one. And the third one, I still have use yn for the result. Now is x of n plus 3 times x of 2n minus 1. Okay, we can look at these 3 signals. So in this kind of signals, this y is coming from x by kind of operation. The first one I times by a 2 on x. So this is a multiplication by a scale on the signal, right? The second one, I still have a 2 times in front of it, but I also have a change in the index. The time index, the original one is n, now is 2n minus 1. And the third one is a combine of 2. First one is x itself, but second one is similar with this part, similar with previous problem, just now this is 3, right? Okay, so we want to know what is the result, what are the results of these y's for these 3 cases. So for first one, just times 2, right? So the same simple, x y of n just 2 of x, so you just copy them, but you need times 2 on it. So 1 now is 2, 2 is 4, 3 is 6, 6, 6, we have 4 3 here, then 4 6 is here, and then 3 2 here, then here will be 3 4 here, right? Double of 2. Then 2 of 0 is still 0, and the initial time is still here. So we have y. We have y. We can also give a graph, right? It looks almost the same way the original one. Just the value was double. So here's 2, 4, 6, 6, 6, 6, then 4, 4, 4, and 0, 0. Right? This is y of n. So we have y of n looks like this. And the second one, now look at the second one. Second one, this time we have some change in the index. So we can work like this. I use the table. I put n here, I put the 2n minus 1 here, then x of 2n minus 1 here, and finally I get y. So I list the possible values here. This is y of n. Right. For convenience, we start from, okay, so n is 0, we start from n0, then 2n minus 1 is negative 1. So n is 1, is 2, 3, 4. So here will be 2n minus 1. So 2 minus 1. 2 of 2 minus 1 is 4 minus 1. 2 of 3 minus 1. So 6 minus 1 is 5. 2 times 4 minus 1. So 8 minus 1 is 7. Right. Yeah, I put the value here. This is n. This is n run from the n0, then 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay, so this is largest n is 8, so I can give more. This is 5. Here with 2 of 5 minus 1, right? 2n minus 1. 2 of 5 minus 1 is 10 minus 1 is 9. Okay, then the value x of 2n minus 1. now 2n minus 1 now is negative 1, first one, right? You look at here, this is negative 1, so this point should be this value should be x of negative 1, and x of negative 1 is here, x of negative 1 is here, 0, x of negative 1 is 0, so the first element here it is 0, right? And the second, n0, 2n minus 1 is 1, so this is x of 1, x of 1, so x of 1, you look at here, x of 1 it is 2, x of 1 is 2, is 2, and then next similar, this is 2n minus 1 is 3, so this point, the value here will be x of 3, x of 3, right? X of 3, whichever, what is x of 3 is here, it is 3, so this is 3. Alright, similar, right? So the next value here will be x of 5, x of 5, so 1, 2, 3, 4, 5, x of 5 is still 3. Then x of 7, 2, right? X of 7, 2, x of 9, 9 see is 0, then 0 value. Okay, finally we can have y. What is y? Y is 2 of this one, right? Y is 2 of x of 2n minus 1, so just double the value here. This is 0, still 0, double, I get 4, double, I get 6, double, I get 6, double, I get 4, then double is 0. Okay, so we have 1. We can write in this way. So y of n will equal to 0, 4, 6, 6, 4, 0, like this one. And here you need to indicate this is according to n equal to 1. N equal to 1. You can also put n equal to 0 this, and there's another. Okay, let me write again. Y of n is 0, 4, 6, 6, 4, 0. Yeah, this is just copied from previous paper. And this place I put n equal to 0 here. Yeah. This one. Yeah. N equal to 0 is here. This is n equal to 1 according to 4. So this is n equal to 0. N equal to 0 is 0. Alright? Okay. Okay, this is one example. This is the second one, right? The second one. Now the third one. That's the example. This is a summation of xn and 3x of 2n minus 1. So y is the summation of these two. How can we get it? We do the same thing. We list the n, value of n, and then we can have what is x of n. Other than x of n, we need 3 of x 2n minus 1. So we need 2n minus 1 firstly. Then x of 2n minus 1. Okay, then you have the summation. Is this one plus 3 of these. If you want, you can also put 3 of x here, also fine. But you can just get y directly, right? Y, which is x plus 3 of x of 2n minus 1. Okay, like this one. Alright, let me put the value. N run from 0, 1. I can use similar with this one. 0, yeah, 0 to 1 to 5. 1, 2, 3, 4, 5. Okay, I got 5. Okay. Yeah, if you want, you can give more in this side. You can also here for small n, you can also put more values, like start from -2, n equal to -2, then -1, then 0, then 1, 2, 3, 4. It's also fine. In this example, we start from 0 is okay. Okay. Now what is x? X is given, right? X is original signal, we have it. So this is x. X when n 0, I have 1, so here's 1, 2, 3, then keep 3. I have 4 3s, then okay, I put 1, 6, 7, 8, 9. Then after 3, the 4 of 3, of these 3 I have 2, 2, 2, 2. Then for n equal to 10s, this is 0. Okay, yeah, this is x. And 2 and minus 1, it is negative 1, then it's 1, this is 3. We already have last time, right? We already have them here. We already have them here, right? Negative 1, 1, 3, 5, 7. Okay. This is 5, this is 7, this is 9. And the next will be 2 of eh? Did I get something wrong? Oh, this is 6, sorry. 6. Yeah, 5, 6, 7, 8. This will be 9. I missed that. Missed 1. Okay, 6. 2 of 6 is 12 minus 1. Then 12 minus 1 is 11. Then 14 minus 1, 13. And 16 minus 1, 15. Then 18 minus 1, 7. Okay, now it's good. Alright, what are the values of x of 2n minus 1? X of, okay, so here 2n minus 1 is negative 1. So x of negative 1. X of negative 1 is 0. So here's 0. The x of 1 is 2. X of 3 is 3. X of 5 is 3 again. The x of 7 is 2. X of 9 is 0. Oh, then the rest must be 0, right? Even larger n's, they're zeros. Alright, we want to have y, right? Y is summation of x, and this x, we do summation. And this one, you just times 1, and this you need times 3, right? Times 3, do summation. Okay, now we do summation. 1 plus 3 of 0 is 1. Next, 2 plus 3 of 2. So 2 plus 6 is 8. Then 3 plus 3 times 2. So this is 6 plus 3. 6 plus 3 is 9. And this is 3 plus 2 of 3 is still 9. Right. Oh, no, I'm sorry. Now 3 times 3 is I confused. Wait. This is 1 times 3 of these. 2 plus 3 of these. 3 plus 3 of these. This 3 of these is 9. 9 plus 3 is 12. Sorry. Yeah. Okay, these 3 and the 2 of these. Yeah, maybe I need one more row. Then things will be easy. Right. 3 of these is 9. 9 plus 3. So it's 9 plus 3, 12. And here will be 3 times 2 is 6. 6 plus 3 is 9. Then here's a 0 times 3. Okay, and then the rest will be easy. Just the 0 times 0 plus. Okay, now we have y. What is y? Y of n, I list all the values. There will be 0 for smaller n, and then we have 1, 8, just this line, right? 1, 8, 12, 12, 9, 3, 2, 2, 2, 0, 0 again. And which one according to n equal to 0? N equal to 0 is here, right? So you put this one here, n equal to 0. Okay, now we have 1. We have 1. If you want to give a graph, then it will look like you have 1, then 8, 12, 12, then 9, then 3, then 2, 2, 2, then 0. Right? So here's a n, here's a y, y of n, y of n. Its value is 1, 8, 12, 12, then 9, then 3, then 2, 2, 2. And if you want to put the value n here, this is n equal to 0, then n equal to 1, 2, 3, 4, 5, 6, 7, 8. This is 9. For n is 9, it is 0. Yeah. Okay. So we have y. We have y. So when you do, if you want to combine different signal together, or you make some change on signal, you can always work like this. You list the value, do calculation step by step. Finally, you can have the result y, result signal. Alright. Yeah, we can look. This is one case. We can look at one more samples. This one, because the original signal is given as a graph. If we have the original signal in formula, then what kind of things can we have? Another example. Now I have x of n, which is okay. I just consider this. It's 1 over 2 to the n times u of n. Yeah, this is a power of 1/2, and we only consider for positive n we have value. For negative n it's 0 because this is u, right? You can know the graph. Use the graph. You can see this is 1, then half, then fourth, then 1/8, and so on. And for negative n, they are zeros. Okay. This is x. And then we want to know y of n equal to x of like a 2n plus 1. And well, this is y. And I have another z of n, which is x of 2n. Okay. And w of n, which is x of n plus 1. We want to know what are these. Y, z, w. What are these? Yeah. Okay. The first y. The first one is y. Y. We can do the similar thing, but here you can also plug in the value to do calculation. Right. Both works. So for this one we can try both, like n x n minus 1, 2n minus 1, 2n plus 1, then it's y, which is x of 2n plus 1, right? This is y. Then I start from like a 0. So negative 1, okay, negative 1, 0, 1, 2, 3, 4. Then here's 2n plus 1, so negative 2 plus 1. This is negative 1. 0 plus 1. 1 times 2 plus 1. And 2 times 2 plus 1. 3 times 2 plus 1. Right? Yes, and so on. Then this one is the value of x at 2n plus 1. Now the first index is negative 1. X of negative 1 is this. It is 0. So this is 0. Then second is x of this 1 is 1/2. Then x, this is x of 3, right? X of 2n plus 1, this is 3. So x of 3 is here, the 1/8. And if you want more, this is the fifth this is 4, this is 5, fifth will be here, right? So this will be 1 over what? This is 1/8, so here next will be 1 over 16, this is 1 over 32, so this is 1 over 32. Alright, yeah, so you can list the, if you want you can have more, like here actually for 7, 7 it will be 5, do more, go more, 2 more steps, so 32, 64, 100, 128, 1 over these, and this will be 1 over also go 2 more steps, so 250 and 5, 12, yeah, so like this. So this is y of n. And can we give a formula for this y? Right now is a list of data. You can write is y of n equal to 1/2, 1/8, 1 over 32, 1 over 128, 1 over 512, and so on. And n equal to 0 is this one. Right? N equal to 0. You can write in this way. You can also give a formula, right? It is a half, then eighth, then 32. So every time you have 4 times, right? 4 times. So you can write y of n as the first number is 1/2, then 1/4 to the n, and also you need a u of n. So this is a y of n. If you want to give a formula, looks like this. This is y, the first one. No, y. All right. Yeah. And the second one. Second one, this one, z, right? Z of n. Right. Z of n. What is this? This is x of 2n. X of 2n. Now I use the method I plug in the formula to get x of 2n. I can also use a table similar with these, but I can also just plug in. So this is x of 2n. And what is x? X is this one. So this is x. If here's n, the index is n, then here's n. Now the index 2n, so here's 2n. Right? 2n. And the u of, here's also 2n. Right? Every time when you have n, now you need to replace n by 2n. So this is z of n. This one looks, yeah, this is 2n. 2n. But what is the u of 2n? U of 2n. U of 2n, actually it is same with u of n. U of 2n equal to u of n. They are same thing. They are same thing. Why they are same thing? You can see this is n, this is 2n, this is u of 2n. You can also put the u of n, you compare these two. When n is like -1, 0, 1, 2, and so on. Then 2n will be -2, 0, 2, 4, and so on. The u of 2n. Now is the u of 2, -2. U of -2 is 0. U of 2n, second is u of 2n, 2n 0. So u of 0 here. U of 0 is 1. Right? And this place will be u of 2. U of 2. So it's 1 again. Then u of 4. This is 1 again. You see? This is u of 2n. And u of n, for negative n is 0. For all positive or 0 n's, it is 1. You see? These two, same. They have same value, right? Totally same value. So they are same signal. They are same signal. So I can write this as u of n. So this is u of n. Same with u of n. And this part, 1/2 with power 2n. I can perform 2 firstly, square firstly. So this is 1/4 to the n. Okay. So we have z of n. We have a formula looks like this. You can also use this one, but this one you can consider this is more simple, right? After simplify, you prefer to use this one as the answer. This one as the answer. Alright. This is Z. Now what is W? W? So what? W? W is x of n plus 1. X of n plus 1. Okay, I can just plug in. It's x of n plus 1, which is 1/2 to the n. Okay. We have x. X, this is half to the n. Now n is n plus 1, so it's n plus 1. Okay. And u of n plus 1. What is this? Okay, I still need to list some values. This part will be easy. That is 1/2 times 1/2 to the n, right? And what is this? U of n plus 1. Can we make some change? Yeah, we can just keep it. This one I cannot make this more simple. Just like this. And we can list the value to see what it is. This value we can base on this to list the value, or we can use x. So can write use x. Just use x. So this n. This is n plus 1. Then this is a wn. Wn, which is x of n plus 1. Yeah, list the value. N run from -2, -1, 0, 1, 2, 3, for example. Then n plus 1 is -1, 0, 1, 2, 3, 4, right? N plus 1. Then wn is x of n minus n plus 1. So here's a x of -1. X of -1. What is x? I'm sorry. X is here. X is here. So when n is -1, it's 0. So here's a 0. When the index is 0, it is 1. When index is 1, it is 1/2, then 1/4, and 1/8, and so on. Right? We get this one. We get this one, and we can have a graph to see. Now we can list the first like W of n equal to 1, 1/2, 1/4, 1/8, 1/16, and so on. With n equal to 0 is here. N equal to 0 is here. So this 1/2 according to n equal to 0. If we give a graph, so when n is 0, it is 1/2. When n is -1, it is 1. And then 1/4, 1/8, 1/16, and so on. Right? So it's like this. And that values, those values will be 0. This is n. This is W of n. We can compare this W with that x. X is here. You see? The waveform looks the same. 1, then half, then 1/4, 1/8, right? Tend to be smaller and smaller. Tend to be smaller and smaller. Half and half and half. But x is start from 0, and W is start from n equal to -1. Right? Start from -1. So actually W of n, it is a shift of x of n by -1. -1. Actually, we can have more generally. We can have this one shift. So Wn equal to x of n minus nd is a shift of x of n by nd. You know, I put minus here. I don't want to put negative here. Like here, W is n plus 1. W is x of n plus 1. So it's shifted by -1. Right? Shifted to negative side. Shifted to this side. Right? If you want shifted to positive side, then here should be plus. should be minus. The plus will change to be minus. So here I say minus. Minus some nd is shifted by nd. So like if this is x of n, then this is a w, which is x of n minus nd, or it looks like this. Here's nd. Here's nd shifted by nd. Yeah, this is shift. Shifted by nd. Shifted by nd. Alright. This is one operation, and let me see what else can we have. We can also have another operation. We can. Okay, I don't have time. Then I will find some time later. I will do that operation. That is a convolution. Like convolution. Later we will use it. Yeah. Today that will be fine. The operation will be fine. Here I just want leave a problem to you guys. The problem is like now every time when you do calculate, in most cases you have a formula, then you can give the graph, right? You have a formula like here you have this formula, then you know for every n you can find the value, right? For every n you can have a value, right? Every n you can have a value. You start from a formula, you can do the calculation. If you start from signal, now we go back, go around the way. You use the backward way. If you have list of values, can you go back to find the formula? Actually, this one we can have a formula, right? I just give one. Let me see which example where I have a formula. Here, like this y. When I get this y of n, I observe the date. Then I found, okay, I can write it in this formula, right? First is 1/2. Then every time, every step, you just multiply 1/4 on it. So I get a formula like this. But in generally, can you have a method to find the formula for a signal? Yeah, this is the problem. Like you observe some phenomenon or do some experiment, then you get a sequence of date. Then can you find the formula for this date? Yeah, you have a sequence of date. You want to find the formula for that. Can you find it? Do we have any method to do that? Yeah, keep this in your mind. And later we will learn one of the methods. So when you have a sequence of date, how to find the formula for those dates. So we can write the signal in a way of formulas, right? We know the signal, we can have different ways to represent it. Like just like this one. Which one? This one, like this one. I can list the date, right? This is one way to describe the signal. I list all the date. And I can also give a formula, right? If you have a formula, of course this is better, because when you have this formula, you can know the value of y for any n. You just plug in n, you can have that date. And if you list the date, then for different n, like n is outside, like n is 12, what will be y? If you just look at this one, you cannot figure out what is the y of 12. You don't know, right? You need to find a formula, then you can have it. Okay, so this is the question. In generally, when you have a sequence of date, can you find the formula for this date, this sequence of date for this signal? Alright, okay, that's all for today. And I think I have one more thing. For the homework, I will give you some homeworks. That will be a homework to cover the first 2 weeks. Some of the homework problems you can already. Oh, I think I explained it, right? Yeah. Oh, sorry. This is the third class. In the second class, I already explained it. Okay, then that will be fine. See you next time.